Find the equation of the tangent line and normal line to the given function at the point -1, 6. Looking at the graph on the right, here's the point -1, 6, and therefore this red line is the tangent line, which we can think of as a linear approximation of the curve at the given point, and the normal line is perpendicular to the tangent line as well as to the curve at the given point, and therefore this green line is the normal line. Notice how the two lines intersect and form a right angle or a 90-degree angle. Let's begin by determining the equation of the tangent line, which is given by y minus y sub 1 equals f prime of x sub 1 times the quantity x minus x sub 1, where x sub 1 comma y sub 1 is a point of tangency, which in our case x sub 1 equals -1 and y sub 1 equals 6, and f prime of x sub 1 is the derivative evaluated at x equals -1, which gives us the slope of the tangent line. So let's find the derivative function, f prime of x, which equals the derivative of x cubed, which is 3x squared, minus the derivative of 5x, which is 5, plus the derivative of 2, which is 0. And now we evaluate this at x sub 1, which is -1. So we have f prime of -1, which is 3 times the square of -1 minus 5. Simplifying, we have 3 minus 5, which is equal to -2. So this gives us the slope of the tangent line at the point of tangency. So the equation of the tangent line is y minus y sub 1, which gives us y minus 6, equals f prime of x sub 1, which you just found is -2, times the quantity x minus x sub 1, which gives us x minus -1. And now let's simplify. We have y minus 6 equals -2 times the quantity x minus -1 is equivalent to x plus 1. And now let's add 6 to both sides, which gives us y equals -2 times the quantity x plus 1 plus 6. And now let's clear the parentheses and combine like terms. We have y equals, distributing -2, we have -2x plus -2, or just -2 plus 6, giving us y equals -2x plus 4 for the equation of the tangent line at the given point. And now let's find the equation of the normal line. The only difference is the slope is going to change. The slope of the normal line is the negative reciprocal of the slope of the tangent line. So notice how for the normal line, the slope is -1 divided by f prime of x sub 1, which again is the negative reciprocal of f prime of x sub 1, or the slope of the tangent line. But it's probably easier to take the slope of the tangent line, which is -2 or -2 over 1, and determine the negative reciprocal, which is +1/2. And therefore the equation of the normal line is y minus 6 equals, again, -1 divided by f prime of x sub 1 is the negative reciprocal of -2, which is +1/2, times the quantity x minus x sub 1, which simplifies to x plus 1, just as it did here on the left. And now let's go ahead and solve for y by adding 6 to both sides. We have y equals 1/2 times the quantity x plus 1 plus 6. And now let's go ahead and clear the parentheses by distributing 1/2, which gives us y equals 1/2 x plus 1/2 plus 6. Well, 1/2 plus 6 is 6.5, or 13/2, giving us y equals 1/2 x plus 13/2. So now we have the equation of the tangent line and normal line in slope-intercept form. Before we go, though, let's verify this graphically. The function is graphed in blue. The given point is this point here. Notice how the red line is tangent to the curve at the given point, and the green line is normal to the curve at the given point, verifying our work is correct. I hope you found this helpful.